The next step in getting the IMSAI 8080 computer from 1975 operational is to interface it with an 8-inch floppy disk system, be able to format floppy disks, and then be able to load CPM from the disks as an operating system. This computer has a disk jockey disk drive board installed. It was designed by George Morrow, and the EEPROM contains all the routines required to read and write to the floppy disk drives. I built a cable, 50-pin flat ribbon cable, which connects to this dual 8-inch floppy disk drive system. This one was made by Intel. The drives themselves are standard Shugart SA800 801s, which are considered quite reliable. In fact, the most reliable of these vintage drives. The only thing that I had to do in this box was to put wire wraps on these interface cards, these vertical cards, which connect the disk drives to the flat ribbon cable. The pin numbers on the disk drives are numbered 1 through 50, and they correspond with the exact same pin numbers on the computer disk jockey board. Unfortunately, Intel crisscrossed the wires between the disk drive and the output connector. So rather than rewire my connector, which is basically wired pin 1 to pin 1 and up to pin 50 to pin 50, I wire wrapped these interconnect boards so that pin 1 from the disk drive would end up at pin 1 on the output connector. It just makes troubleshooting that much easier. The disk jockey board also contains a serial port, and I've wired that through this little serial port monitor, which monitors the data transmit and receive lines, and I have that connected to a Windows machine running Windows 98. And the terminal that I'm using emulates a VT100 terminal, and that is the window. Term is the program. So the first step is to get a bootloader loaded into the IMS computer, and I've written here some code which basically looks at the output of the Term serial connection and stores those bytes into a specific memory location in the computer. I couldn't use the EEPROM routine that was supplied with the DJ board because it strips off the 7th bit because it's expecting ASCII characters from the terminal. That's a disaster when you want to transfer binary files. So I rewrote that code here, which just basically writes directly or reads directly the serial port register on the DJ board without stripping off any bits. So let me key this program in and load it. First thing we do is load the disk jockey EEPROM at F8 into the disk jockey RAM, which is sitting at the very high end of memory. Okay. Now I load the bootloader program in. 21. Starting at address 0. 21. 00. 01. 0100 is the address where the programs will be loaded into memory. 3A, F9, FB, E6, .04, C2, 03, 00, 3A, F8, FB, 2F, 77, 23, C3, 03, 00. Reset the program counter to the beginning and run the program. It's now waiting for a file from the Windows machine terminal emulator. I have a Nixie tube frequency counter hooked up to the M1 line of the computer. The M1 line is the fetch instruction line. So every time that line goes high, an instruction is being fetched. So this actually shows the MIPS of the computer, how many instructions are occurring per second. And it depends on the clock of the computer, of course, and also the efficiency of the code. The number here shows 386,000 instructions per second. This is right in line with an IBM 360 and early 370 mainframe computer. So it's quite impressive. So the computer now is waiting for a program, and what I will do is send it the disk drive formatting program. So we go to File, Send File, Format number sign BD.com. And open. It's now sending the file, and it's done. It's now loaded into memory at 0100. Now this program, format number sign, is a disk jockey format program from the 1970s, but I had to modify it. I had to patch in code to replace BDOS calls in CPM because I don't have CPM. So I have to make this operating system references have to be taken out completely. So what I'm doing instead is I've added some subroutines at the end of this program. The calls are made in place of the BDOS calls, and I used the same number of bytes so that nothing would shift in the program. It had to be done in 3 places because there are 3 BDOS calls. So basically they use the disk jockey EEPROM I/O routines for the serial port rather than calls to the input-output of CPM. So it is a modified version of format number sign.com. It's now loaded into the computer. So let's see if it works. So we stop my bootloader, and we have to go to 100. That's the start address of the format program. Now before we run it, let's turn on our disk drive machine, and we've got to put a floppy in there. I have here an 8-inch floppy. Okay, so let's run the program and see what happens from 100. And there we go. It has actually begun executing and writing on the serial port to my Windows machine. Disk Jockey 2D disk program, format program. Select drive A, B, C, or D. Well, of course I will select A, and it asks for the format mode and I will choose the 1024 byte double density mode, because this is a double density disk that I put in there. Just keep in mind that there are 77 tracks on an 8-inch floppy disk, and track 0, which is the first track, will always be formatted as 120 byte single density. So that's 26 sectors of 128 bytes each. But from track 1 onwards to track 76, which is the 77th track, those will be 1024 bytes times 8 sectors each. So anyway, there's the choice, number 4. Insert a write-enabled diskette in drive A, close the drive door, and then press return. It's already done. Ask me one more time. I don't know why it does that. And there it goes. It's formatting the disk. And there's an asterisk put down on the screen for every track that has successfully formatted. Done. Format complete. This is the Disk Jockey 2DB format program, FORMT .com, modified to remove CPM references, and it is now running on this computer. And I have managed to format a blank 8-inch floppy to 1024 bytes per sector, 8 sectors per track, except track 0, which is 26 sectors of 128 bytes each. Now, after we have successfully formatted a disk, I would like to be able to read or write any sector or groups of sectors on any track or groups of tracks. I will need this to patch CPM from a known CPM source onto these disks in order to use the system and boot CPM on this particular machine. So the first step in all of this is to write a program that enables me to read and write any sector on any track. So what I have done is I have written a program that I've called RWDJ. It's sort of a source file. I don't really have an assembler here. It's all hand assembled what I do. So we'll open this file. And basically this is an assembly language program that I wrote. And it uses the DJ board EEPROM to read and write to and from the memory in the computer. So what we'll do now is prepare the bootloader to load that program into memory. Right now the format program is still running here. You can see the MIPS from that program. So I will stop this and I will go back to my bootloader program, which is at address 0, and run it. And now I'm waiting for a program transfer from here. We'll use the terminal and we will file, send file, rwdj.com. Done. The program is now on this computer, so I stop the bootloader from running, and at address 100 I can begin the disk read write program.